Okay, so this is LeetCode number 1 called toSum. So given an array of integers, nums, and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can't just, for instance, if you have the target of 6, you can't use the same 3 at the same indice. For example 1, we're given this is our nums array, and the target is 9. We would output an array of 0, 1 because the 0th index corresponds to 2, and the 1 index corresponds to 7, which those two added up give us 9. Same with this, except that the first index and the second index added together give us 6. One thing to remember is that indices start from 0, start counting from 0, so this is the 0th index, this is the first index, this is the second index. Okay. And this one will just give us 0 and 1 because 3 and 3 gives the target of 6. Okay, so how will we solve this? So let me bring out a little tool. So at this point, we're gonna have to look through this array, right? So at this point, we found 2. Once we found 2, let's go over the naive solution. So the naive solution would be to look at 2, and then while we're at the index 2, what do we need to add up to 9? Well, we needed a 7, right? So we just look through the rest of the array and we find 7. We'd find our 2 values. Okay. What if this 7 was all the way over here? Then we would have to have basically 2 loops, right? We'd have to have an O of n squared algorithm to do 2 loops, to first look at the first value, then look at the rest array for the target value. That's not the most ideal. What we can do is we can do it in one pass. So we can do, let's look at 2. Okay, and then let's store this 2 in a hash map. So in a hash map or a dictionary, however you want to say it, and let's say this is at the 0th index, right? Okay, and then let's store a value called complement. And this is just going to be an integer value. Okay, at 2, we're going to calculate the complement to be 9 minus 2, which is 7. Great. Okay. We look in the dictionary. Is the complement in the dictionary? It's not. So then we just add the indice, the value to the dictionary. So the steps are going to be calculate complement. So calculate complement. See if complement is in dictionary. If so, then I don't know why this tool keeps coming up. Then return. This is kind of annoying. Okay. I'm getting frustrated with this. I'm just gonna put it in a comment up here. So let me just go back. Stop using this tool. So calc complement, see if comp and dic, if so, return current index comma, the value of the complement, because that'll be the indice of the complement. Okay. If not, then add value to dictionary. Okay, so that's gonna be our algorithm. Okay, so let's go ahead and start with this. So let's create a dictionary. So complements is equal to an empty dictionary. And then we're going to do a loop, for loop, for I in range, length of nums. Cool. So it's going to give us indices from 0 to the length of nums, except we're going to stop at the last index. Okay, so if actually let's calculate the complement first. Complement, scratch that. We're gonna store the current value into a variable. So we're gonna do current value is nums at I. So whatever current index we're at, we're gonna index into the array, and we're gonna store that into current value. That makes sense, right? So if the index was at 2, then we're gonna store 2 into the current value. Okay, and when the complement is just gonna be target, or in this case would be 9 minus the current value. Okay. We go ahead and just remove this. Oops. Just delete all this right here. That's much easier. Okay. Cool. And then I'm gonna do if complement in complements. Then we're going to do return current index in this array format. So it's going to return as an array because they want us to have that format. Then it's going to be complements sub complement. Cool. And then I guess we don't really have to put an else because this would just automatically return and this whole function would end, but we could just put complements sub current value is equal to the index. Okay, I think that would work. Yeah. Let's see, just go ahead and run it. I might have made a mistake. Cool. So that's the solution. So what is the runtime and space complexity? Okay, so runtime is equal to big O of, what would that be? Well, big O of n, I believe, because we're only doing one loop for the length of nums, where n is the length of nums. Length of nums. Cool. Space would be O of n as well, because n is len of nums, because we have to store, at the worst case scenario, we'd store all of the complements into this dictionary, and that would grow with the input size. So as nums grows, our space that we need to use is going to grow as well, and that's going to happen linearly. Cool. So